Okay. Well, thank you so much for your time today. We are about to start the webinar. My name is Sanjay Patel, and I'm here with the WebFirst team. We're very excited to be working with you today and to talk about this new exciting technology called blockchain. Okay, so your presenters today, again, it's Sanjay Patel. I am owner of WebFirst. We've got Ted Gifford here on the phone. He's one of our senior developers with over 15 years of experience working in web and mobile technologies. And we have Kevin Rux here today as well. All right, so just a little bit about why I wanted to give this presentation. You may or may not know WebFirst is very involved in the government contracting realm. When I first learned about blockchain, thought about how contracting works, how the procurement system works, and I thought how much easier it would be if we could use blockchain for developing contracts, signing contracts, and making payments. It would cut out a lot of the inefficiencies and a lot of the slowness involved in executing contracts. So that was really the genesis of my thinking here. And so I'll talk a little bit about the journey WebFirst is going through with respect to blockchain as well a little bit later. So just really briefly about what we do. We're strong in web design and consulting. We're Drupal developers. We've got over 8 years of experience working directly with Drupal and Drupal 8. We're working with IoT and home appliances, quite a bit of development with Google Home, Alexa, and Apple as well, Apple Home. We're also strong in developing native mobile apps with Android and iOS as well. Okay, so public sector. These are the verticals that we're most familiar with, that we're working in directly. We're very strong in federal government. For those of you for which this has meaning, we're on several contract vehicles, 88 stars, CIUSP3, and I-270. We're also in the nonprofit world quite a bit with health, education, and agriculture. Some of the clients we're working with, NIH, USDA, Voice of America, Department of Justice. You can see a couple of examples here for who we're working with. All right, so goals for the webinar. We're really interested in starting or continuing the conversation about blockchain in the government. Our company is on a journey of discovering about blockchain, how it can be used to help processes and supply chain be more efficient. We see this as a continuing dialogue of how blockchain can be leveraged. So the purpose here for this webinar is really to share our experiences back to the community. We don't claim to be experts in blockchain necessarily and know everything to everyone, but hopefully we can share and also learn from you as well. So the goals for this webinar: gain a better understanding of what blockchain is, understand why the system is designed the way it is, provide some use cases for ongoing and future work, and also to introduce our work, WebFirst work, in this area of blockchain. So that's what we'll go through today. Hopefully we'll meet all of these goals. Okay, so blockchain. What is the blockchain? The blockchain, think of it as a secure ledger. Really, it's a place where transaction information can be stored securely and transparently so that people can see who signed what and when, right? So it's just think of it as a secure ledger. At its heart, it's a database with records, but a much different kind of database than you're probably used to. Every record has a unique and unhackable identifier. So I do want to mention that I'm going to be a little bit loose in terms because of the varied background of information of different types of people we have on the call today. But for those of you with a computer science background, you may refer to this identifier as a hash or key. So we're just going to use identifier in this case. So the record lists the details of the transaction. So the record itself has the meta information, the transactional information, the date and time stamp, who signed it, those kinds of details. Those are in the record. The next record references the ID from the previous record, chaining the records together. So this is one of the key concepts of blockchain, right? So the ID of the previous record is incorporated into the next record. And so changing the ID in one record disrupts the whole chain, and therefore you would know that it doesn't fit and it's not a valid record. So this is a really key concept, and it goes right to the heart of trust with blockchain. We could see who wrote every record, because every record is timestamped and signed by the parties, and miners solve a complex puzzle to add the record to the blockchain. So just a little bit about miners, because this is definitely a tricky area. So the record does not fit into the blockchain directly, right, when a new record comes in, a new transaction. Every record has two edges, one that's been accepted and one edge is for the future. The miner figures out the solution of the puzzle, right, it's going to be some complex algorithm to figure out how this record, this edge of the record, fits onto the next record for the blockchain. This is a difficult cryptographic problem. We're not going to go into the details of that. Just trust me that once the miners solve the problem, the record's verified and it's added to the blockchain. And then trustless. Okay, this is another key concept of blockchain, that all steps can be verified, minimizing trust from any single actor in the system. So trustless does not mean there's no trust, right? There's no trust in the system. It just means the trust is distributed and that people trust the algorithms that are behind the blockchain. So that's really what this term trustless means. So these are some key concepts of what the blockchain is. So try not to overthink it. Again, a secure ledger with all of these features. So cryptocurrencies versus blockchain. So you've probably heard Bitcoin, Ethereum, Ripple, Litecoin. All of these different coins are cryptocurrencies. Bitcoin is, and all of these are a digital, decentralized currency for allowing the safe, secure transfer of funds between users directly, right? Bitcoin is structured as a blockchain. So on your screen, you probably see that blockchain, you see a picture of Bitcoin, right? There's no such thing as an actual coin for Bitcoin. The actual Bitcoin is a transaction that's actually recorded to the blockchain, right? It's just a transaction that's recorded to the ledger. So they're very closely related and closely intertwined, the concept of crypto and blockchain. A blockchain is a distributed ledger that maintains the immutable records cloned across many nodes across the network. And blockchains have been employed by companies since the early 2000s. So it's really technology that's been around for quite some time, and only now it's becoming more mature, especially with the advent of these different coins. And, as you may know, there are some coins that are devoted strictly to a particular industry. For example, Pavo coin is a coin that's developed for the agricultural industry for supply chain and food safety purposes. So there are different cryptos that are for different purposes. So concepts to note. Different industries will have different chains. So there'll be finance, ag, health, and government. They all may have different chains. Each ecosystem is promoting their own blockchain. So Ethereum has their own blockchain, Bitcoin, and so on. Blockchain replaces intermediaries. All transactions can be verified. So really, what's the beauty of blockchain is that we can replace the blockchain with intermediaries. So you can see instantly things like escrow accounts, right, especially for real estate transactions and so forth. No need for this with the blockchain because the funds will not be released until the various steps in the process have been verified. Have the deed of trust been signed and so forth. And so these are things that where blockchain can come in and completely disrupt the supply chain or processes of many industries. Reputational opportunities. Your score goes up as you transact more. Reviews can't be forged or altered as well. So the more you transact, the higher your score is. And so this gives you the opportunity to have high score, trusted more, as your trust goes up, you're able to, promote yourself as a trustworthy source for transactions. And so that's a huge benefit. So these are all a step up from what we currently have. So I'm going to provide a use case in agriculture. The government of Kerala in India is planning to introduce blockchain into the grocery supply process, ensuring that the system will be used whenever food is being delivered. So millions of people rely, in India of course, and elsewhere, rely on a daily basis for products to be delivered to them. So the blockchain provides a form of crop insurance to ensure farmers can be compensated quickly when unforeseen circumstances affect their yield. So really, because all of the events, from farm to market are being tracked, right, we can see where there's accountability along the supply chain, and this, in effect, provides a form of crop insurance, so we know where to go, who the responsible parties are, who needs to, be aware of what goes on within the chain. So now I'll come to a potential use case. One of our clients is the USDA Agricultural Marketing Service, and their part of their division is involved in the Perishable Agricultural Commodities Act, which is an act of Congress in the produce space, produce, fruits, and vegetables. So fruit and vegetable producers and suppliers need to have a license in order to transact in this area. PACA is involved in charge of that. They also help resolve disputes between the retailers and the shippers. And so while we haven't done any blockchain in this area, there's great potential for blockchain to improve efficiencies and disrupt this whole supply chain process here. So I'll go over this quickly, and then I'll show it to you in a pictorial way. We've got growers who grow and package the oranges. The carrier, the trucking company, ships the oranges to the destination, for example, the Port of Miami. And so in this example, we're talking about shipping produce from U.S. to France. And so they arrive at the Port of Miami. The USDA inspection of the fruit occurs in Miami. The bins are then loaded onto the refrigerated shipping containers at the port. They spend about 2 weeks at sea where temperature, humidity, and the environment are monitored carefully. And then it's delivered overseas to their final destination where they are inspected again. And so it's very important that every event along the supply chain is tracked and verified, such as temperatures, inspections, and so forth. And so at the final destination, there are times where the fruit, let's say the oranges, will come back and there'll be decay, or rotting issues. And so this is why in a dispute, we want to know who's going to take responsibility. Did the shipper follow the proper procedures? So all of these kinds of things with information that is immutably and securely stored in the blockchain can be verified much more easily and readily than current processes allow. And so again, with the blockchain, we can say who, what, where, when, how. It can't be tampered with, and it's recorded, increasing the confidence of the data. So here's the diagram or the pictorial view of this. We have potential use cases with the players being the inspectors and the two contracted parties, the shipper and the buyer in this example. We have the blockchain here. Now each of these parties have their public keys, and they'll upload their public keys to the blockchain. And think of these keys as identifiers, right? These are I'm using that general term here, but these keys identify each of these parties uniquely. It's your unique ID that identifies you. So step 2 here, the PACA contract is uploaded, right? Because we want to make sure that everyone agrees to the same terms. How are they going to be shipped? How long? What's the duration? What are the rules for disputes and so forth? Both parties, the shipper and the buyer, consent to this contract, to the PACA contract. And if somewhere down the line a version 2 is created, that would be uploaded. And then in this example, we're currently, only the shipper has responded with consent. We're still waiting on the buyer to consent to this revised PACA contract. So again, a very clean way of showing how blockchain can be used. Okay, so moving on, now we've got signature consent on the PACA contract. The grower will pack the shipment. The humidity, for the trucking will be reported, humidity environmental controls. The inspection will take place at the Port of Miami, where it arrives, scanned at Miami, and inspected at Miami. It's shipped now. You can see the little boat. Now it's on the boat sailing overseas. And, of course, all along the way, these events are tracked and set as well, the humidity, the temperature, and so forth. And finally, it's inspected at the destination. So again, a very clean, secure way to track all of these events and transactions in the blockchain, so there's no misunderstandings. No one can say, I didn't receive X, Y, or Z. We all know where things happened and when. Okay, so again, that was an agricultural use case of applying blockchain. Now we're going to talk a little bit about the use in clinical healthcare and medical research. And so, as you may know, because of the sheer size of the healthcare industry, there's a huge amount of data that needs to be protected, verified, and shared. Just from a transactional basis, patient records, for instance, EHRs, those kinds of things. From a cost standpoint, we're talking about $250 billion to spend on healthcare alone. Blockchain technology can reduce this significantly. So not only in the areas of patient records and sign-off and so forth, but also in terms of medical errors, right? So we're talking about 80% of mistakes in the healthcare industry are administrative, and they harm 400,000 patients a year. So we can cut down on human error. We can decrease costs by incorporating this technology through a distributed ledger. That's the beauty of the blockchain. Okay, so that's clinical side. As a company, we are more so involved in the medical research part of it with our NIH work, and informed consent is a huge part of any research process, for those of you who are familiar with the clinical research side of things. So the FDA has, so let me talk about informed consent a little bit. As you know, informed consent is the ability for a patient or a research participant to sign a document that says they understand all the implications of the study or the treatment they're receiving, that they know the dosage, that they know what kinds of things they're going to be receiving, and so that they accept the risks, right? So that's what informed consent is. It's really about, trying to protect and inform the patient to the extent possible with any of these studies. And so the FDA has reported on the frequency of trials that have issues with informed consent, where almost 10% of trials have problems with consent collection, such as the failure to reconsent when something changes, forms aren't signed, or missing dates or missing pages, and so forth. So again, all of that goes away with blockchain, right? Patients can't say, I didn't receive consent. Investigators can't say, well, I never received consent, so our study's taking, 6 months or a year longer. All of these things, again, are immutably stored in the blockchain. It also improves transparencies. All designated parties can see who signed the document and when. And right now, Dr. Benchoufi, who I sourced, he's working out of Paris on a clinical epidemiology project where he is doing a prototype, or he has done prototypes of using blockchain to track informed consent, and he's doing that currently, and so I recommend reading his paper as well. And he talks quite a bit about the problems, the benefits and problems that he ran into. All right, so to map this out, this informed consent process, we've got the investigators and example participants. Here we have again, they have public keys identifying each of the participants. We'll upload the informed consent or the protocol as a version 1 that gets sent up to the blockchain. We have participant number 1, or the top participant, consenting to version 1. Well, we have participant 2, and these are, again, just representative, right? Participant 2 has declined version 1. So now participant 1 is presumably okay to be in the study, assuming all the IRB kinds of things are completed, right? If there's a change to the protocol or the informed consent, that would show up as a version 2 on the blockchain. And again, with version 2, we have consent by the first participant. So again, very nice and clean workflow. Everyone knows who signed when, and there's no room for dispute or changes to any of the answers here. I'll leave that up for a moment. Okay. So with any technology, you're going to see pitfalls, right? No technology, no system is perfect. Let's just talk about costs. There are uncertain costs with this technology. You may have heard of the concept of gas, and again, I'm not going to go too deep into that, but anytime a miner, anytime you send a record to a blockchain, let's say Ethereum, there's going to be a cost associated with that. And so depending on different factors, you may pay more, and that's called gas. Also, miners need to, the more you pay a miner, the faster the miner will actually solve the puzzle so that it gets accepted into the blockchain. So again, all of these are uncertainties in terms of getting onto the blockchain. There are no guaranteed acceptance of the transaction. So, you could be waiting for party 1 or party 2 to sign off. So you don't know when, there's no guarantee of acceptance of the overall transaction. Variable timing, right? How long will the transaction take? What are the miner's response times? Again, these are things that could take significant time waiting for each one to happen. So you need to factor that into the equation. Lost or stolen wallet, right? You could lose your key. Your key could get stolen. It's very important when you're dealing with these transactions that you hold on to your key, because that's your identifier. That identifies that you are the owner of this cryptocurrency, that you are the person that signed off on a transaction, and so forth. And malicious or fraudulent smart contracts. So there's a trade-off, right? The more complex your smart contract is, the more likely terms could be hidden, right? Just like a paper contract. You could hide terms one party could hide terms in a very long 50-page contract. So if a contract's very complex, it may be difficult to understand all the implications, right? A malicious person could sneak in something like, hey, I want to take a 30% cut of all the transactions that occur. So these are still things, the blockchain is not going to solve all of these problems, and there's still some things that you need to look at in terms of risks and potential pitfalls. Okay, so now I want to switch gears a little bit and talk about Web1st's work in the blockchain. You're really taking a sneak peek at what we're doing internally in our R&D. We've got a proof of concept calling DC100. It's a decentralized app, or dApp, that we're working on. You have the browser, and I'll talk a little bit about how this works. It's really a framework, a general conceptual framework of tracking processes and events, just like the ones we've been talking about, over their supply chain. And so in this example, we have a document you see in the top right where the document is stored. So the browser is using React, which is a JavaScript framework, and MetaMask is the wallet. We send the document through Express Server to something called IPFS, which is the Interplanetary File System. We get a document ID back once it's stored in that file system. And then when we want to sign this document, right, the document could be a deed of trust in real estate. It could be the PACA contract, and so forth. Once we sign that transaction, that signature information and the meta information about that document is stored in Ethereum. And now, or I should say sent to Ethereum. Now the step of mining needs to occur, and then we request the miner, and then it becomes available on the blockchain once it's solved and verified. And so you can see the different technologies we're using here. It's not terribly complex, but there are a lot of newer technologies. I mentioned Truffle. That's what we use to deploy to the blockchain, and then we're using some other languages as well in here. And so here's just another look at the same project in just a different workflow. And on the right, we have an example of shipping routes where we're tracking shipping routes, and again, the humidity, temperature, and other events as well. So we're expecting this to have a version 1 sometime in the spring. Okay, so in conclusion, we're talking about blockchain use cases. They can be seen across many industries. Blockchain helps to greatly increase the trust factor between parties, right? There's no more middleman. You don't have to trust the other party that they're going to send you the funds, that they receive the goods, and so forth. All of that is handled within blockchain. Blockchain has the ability to revolutionize any of the industries that involve transactions. So, I've been talking, a lot about government and healthcare, but think about the hundreds of thousands of transactions that occur on e-commerce sites, Uber, Airbnb, healthcare, organic labeling in foods. I mean, I'm really excited about the opportunity that blockchain brings, how it can streamline and increase this trust factor across all of these industries. And finally, experience in the private sector will lead to improved governance in the public sector. So, I think this works both ways, but we're going to see, as you know, exponential growth in blockchain. A lot of that will cycle back private sector to public sector, and we see some great things come out of that. Great, and so it's just about 2:30, I believe, and we're happy to take some questions from the audience. If you could, please mute your microphones. We're only taking questions via the chat box, and so if you wouldn't mind chatting WebFirst on your chat box for WebEx, we'll be able to answer them pretty much in order. So if you give us a couple minutes, we'll take a look at the questions, and we'll start reading those off. Thank you. If there's any questions, please feel free to post them on the chat box. If you're using the WebEx desktop tool, it's at the top, and there's a chat function at the top of the menu bar. Okay, well, so while I guess we're not seeing any questions to date, but, I do want to mention, and I have the slide up on the screen, that for any of you that want to ask questions, we're happy, again, we're happy to be a sounding board for you and to answer any questions that you have. Again, we really feel strongly about this being a community effort. We do a lot of open source work, and so I'd love to hear from you separately. Email us at info@webfirst.com, and we can definitely get back to you pretty quickly. I will share the slide deck, and we will have a recording as well that we'll post on our website. We'll send that to all of the participants who have signed up to the initial web registration. Thank you for that question. Oh, okay. Well, I want to thank everyone again. Last call for questions. If you've been working in blockchain, we'd love to hear from you. Any questions you have, info@webfirst.com. And I thank everyone for your time and attention. Have a great rest of your afternoon. Thank you again.